Welcome to section 9.9. This is the 80th session of the CISSP exam prep series. In this session, we'll unpack real-time operating systems. We'll answer 4 questions. What is a real-time operating system, and what is it built to do? What is the difference between hard and soft real-time? How does it decide what to run next? And what security risks come with these systems? Why does this matter beyond the exam? Because these systems run the things that cannot wait. Picture an insulin pump dosing a patient, a factory robot arm on a moving line, and a drone holding its position in wind. Each one must react the instant data arrives, with no lag. When you understand how these systems trade features for speed, you can see exactly where their security thins out. So, what is a real-time operating system? It is an operating system built to handle data the moment it arrives, with almost no delay. It usually lives in read-only memory, so it boots fast and stays fixed. The whole design bends toward predictable timing above everything else. Think of a reflex, not a decision. Your hand pulls back from a hot stove before your brain finishes the thought. That is the kind of instant, guaranteed response these systems aim for. What is the difference between hard and soft real-time? It comes down to how much delay you can tolerate. A hard real-time system allows essentially none, because lag could hurt someone. A self-driving car braking for a pedestrian lives here. A soft real-time system accepts a little slack under normal conditions. The tiny lag between a stylus and the line it draws on screen is fine. Same goal of speed, but very different stakes when the clock slips. How does a real-time system decide what to run next? It uses one of 2 switching styles. An event-driven system jumps between tasks based on preset priorities, so the most urgent job wins. A time-sharing system switches on a clock, giving each task a fixed slice of time. You choose one when timing and scheduling are the single most critical part of the job. Picture a traffic controller who either reacts to whichever emergency is loudest or works a strict rotation. What security risks come with these systems? The trouble is that they are lean and single-minded, so there is little room left for defense. They often run custom or proprietary code, which can hide unknown bugs waiting to be found. An attacker may flood one with junk data or bogus requests to overload it and knock it off its timing. So you wall these systems off, use isolation and watch their communications closely to catch abuse early. So let's bring it together. A real-time operating system processes data the instant it arrives, with timing as its top priority. Hard real-time forbids delay where safety is on the line, while soft real-time tolerates a little slack. It switches tasks by priority when event-driven, or by the clock when time-sharing. Its lean, purpose-built design leaves scarce room for security, so you isolate it and monitor its traffic. Respect the timing and guard the gaps that speed leaves behind. The MCQs covering all the topics and concepts from this session are available on RooCloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.